Okay, so hello everyone. Good afternoon, at least for my time zone. My name is Baruch. I'm going to talk about MySQL as a document store here at Wix. How we're using MySQL as almost as a document store, and we're going to talk about all our trials and errors and what we found and how we're using today MySQL as a document store and JSON. So let's begin a little bit about myself. I'm a senior DBA at Wix for the past 3 years almost. I started as a Linux and sysadmin, and I'm a DBA from about 2000. I'm working with MySQL for the last 20 years, from I think version 4, 5.1. Also, I'm talking in conventions like Geek Week in Israel, mostly in Geek Week and MySQL user groups, and that's it. This is, you can see my GitHub, and if you want to talk to me, and you can leave comments also in my Twitter. This is my Twitter handle, so you can look for me there. Okay, so what we're going to talk about today, we're going to talk about a little bit about Wix and what we're doing with JSON, a little bit about in MySQL, also how we combine a document store with RDBMS, how we are using today and going to use in the future JSON and MySQL. And a little bit introducing about generated columns in MySQL, and a little bit of example at Wix, what we're doing now at Wix, and a real world example. And 2 words about our benchmark. We did a benchmark to compare blobs and JSON, and I'm going to talk about very few words about that. Okay, so a little bit about Wix. We give over 150 or 2,000 million users the tools to build advanced web apps. Firstly, we are creating just web apps, web pages for users. We're storing the web page, we're displaying the web page, we're creating web page, we're creating lots of apps like bookings and CRMs, and we have lots of unique apps. Because we have lots of apps, we have lots of microservices that control those apps, that display these apps, and we have lots and lots of microservices. And in one day, we have more than 200 changes in one time. So you can see that we have lots of changes in the database and in the application, and we need to support, our DBA team need to support all those changes. It's very hard to support so many changes in one team, in one event, because there can be more version in Wix than world population or world atoms. So it's very hard to manage so many iteration of data. So I'm going to explain how we do that, and a little bit about how we're using MySQL and Wix. For now, Wix is the main. MySQL is the main database at Wix. We're using MySQL as the main database. We are also using MongoDB and Cassandra, Elastic, and Redis. We're using the Community Edition, not the Enterprise Edition. We have from 5.7.19 to 5.7.26. We're now moving to 8. We're transitioned to 8. It's still not production, but we're working on it. We have more than 1,500 database servers in 80 clusters. We're using Amazon, Google, and Wix Cloud. We're using GTAD replication. If anyone knows what is GTAD replication, we're using GTAD replication. We're using Proxy SQL to route the traffic, and Orchestrator to control the replication. Orchestrator is an open source software created by GitHub and it's very good to control MySQL topology, and we're using that to control all our replications. And also we have in-house software called Shepherd. We hope to open it to open source soon. It's an in-house software created in Go language that controlling all our topology and all our failover. So we can failover between DCs and between sites. So this is an example how Wix cluster look like. This is a very small example of how Wix MySQL cluster look like. And we have, for example, 2 DCs, and we have multiple servers. We have two masters, and we can control with Shepherd, with the open source software that we created, we control the traffic between the 2 masters and between the slaves. We control the traffic with proxy SQL. So this is how we're using MySQL in our topology. So what is essentially Wix? Wix is we stored website. We stored lots of web pages for customers, and the customer can create lots of web pages. They can create whatever they like in the web page. They can create a code. They can write a code. They can use the GUI to create the pages. They can add apps to the web page. We have lots of apps like booking, like CRMs, like gallery. We have lots of apps. So everything everything is saved inside the MySQL. Everything is converted to a JSON. Everything that you see, all the apps, every picture, everything, every link is converted in the end to a JSON. So we need to keep lots of JSON, lots of JSONs. Every app can keep their own JSONs, and every web page is becoming a JSON itself. So our main goal is to keep the JSON and work on the JSONs and edit the JSONs. So in the past, so for example, we have lots of microservices, and each microservice can keep JSONs, and they can keep JSONs in different databases, and they keep JSONs in different formats. Okay. In the past, we used to keep the JSON as a blob. Okay. Because we didn't have any support in MySQL for JSON, so we keep everything as a blob. So we had lots of JSONs, and every JSON was kept as a blob. And while using JSONs, so developers want to use agile way of working. So they want to add attributes. They want to change attributes. They want to do it fast. As you can see before, we have lots of experiments, lots of changes, and they want to do the changes very fast and very agile. And JSON is the best way to keep the data without changing every time the tables and the relation between the tables. And it's very easy to develop over JSON. But we are the DBAs, and the DBAs see the data as structured, and it's very hard for us to structure the data and create indexes and create queries on top of the JSON. So here come MySQL Document Store from 5.7.19. From version 5.7.19, MySQL supports JSON data type. And what we're getting in JSON data type, we're getting JSON support inside relational database. So we're getting all the benefits of relational database. So we have data integrity, we're normalization, we have constraints, we have ACID compliance, we have everything. Also, we have SQL, and we have the ability to work with JSON. Why we like to work with JSON? Because it's schemaless. So we don't need to use the schema. We don't need to normalize the data. No foreign keys, no data types. We can put in the JSON whatever we like. We don't have to insert a float or integer. We don't have to care about that. We can change whatever we want. We don't need to alter table if we change the schema inside the JSON. So it's very flexible data structure. We can use embedded arrays on the objects. We don't need to create embedded data types. We don't need to create strings and very complex code inside the database to support arrays or heritage inside arrays. It's very easy to work with the JSON. So it's very simple to developers to work with the JSON, and for the DBA, it's very simple to work with database, with structured data. So we wanted to provide the both of the worlds. Okay. So we wanted to provide also relational support and also NoSQL support, like JSON document or the seamless JSON collection, like in Mongo. So this is what we tried to do. So in MySQL 5.7.19, we have the support of JSON data type, and we started to test it, and we saw that it's very good, and we really like to move to the JSON data type, and we like to move from blobs to the JSON data types. So let me talk a little bit about the JSON data type and what we found useful in this structure. So in 5.7.19, you can store JSON data inside the table column. It supports UTF-8 MB4. I will talk a little bit about this later, but it's very helpful for us to support UTF-MB4. It can validate the format. So it's validate format. When you insert JSON inside the JSON data type in MySQL, it can validate the format. You cannot insert unvalidated JSON. So it's very helpful if you just insert not a JSON format, it will give you exception. Internal binary format, it's like a BSON, but not exactly like a BSON. If you know what is a BSON, BSON is it's a binary JSON. This is how Mongo is saving the data inside their data files. So MySQL adopted a BSON-like format. So in 5.7, it's a very compressed and very helpful to save it in BSON. From 8, you can do a partial update. It means that you can update part of the JSON. So you don't need, if you update the JSON, you don't need to change all the document. You can do a partial update. But in 5.7, you have to change all the JSON document if you want to update. This is one of the reasons we want to move to 8. You can use it with SQL. I will show examples how you can use JSON queries inside SQL. And you can convert to and from a string. So if you're keeping the data inside the JSON data type, you can extract it as a string and you can insert a string as a JSON. It's very helpful to move from other systems or from other databases that are not supported JSON. Okay, so a little bit about the character set. We wanted to use UTF-MB4. It was a big goal for us because UTF-MB4 is more compressed and also it supports emojis. And we wanted to support emojis inside MySQL. And it was a big issue in our system to support emojis. And to support emojis, we needed to keep the data in blobs as binary. And this was a big issue because we wanted to not to use binaries, not to use blobs inside the database, and we wanted to use emojis and every other strange character set, and also to support queries and indexes and everything else. You cannot index a blob. It's very hard to index a blob. So the benefit is that we can now support emojis and other languages inside the JSON. So JSON data type is supporting UTF-MB4. So we have two goals that we achieved here. get out of blob, and also supporting emojis. So if you are using ASCII or UTF-8, you can still convert. So you don't need to convert because UTF-8 and ASCII are subsets of UTF-8 and before. So the conversion is very easy. You don't need to convert. You don't need really to convert the data. You just can insert the data inside MB4, UTF-8 and before. So we have we have small limitations to MySQL JSON data type. Okay, so you need more space, about 4 to 10 bytes additional storage for which document JSON, if you're keeping it in JSON data type instead of blob, because JSON data type keeping more information about the JSON document, so we need a little bit more of storage to keep the JSON, to keep it inside the JSON data type instead of keeping it as a string or keeping it as a blob. Okay, so also we have a maximum size of a JSON. The maximum size can be 1 gigabyte. The maximum size is it comes from the max allowed packet. There is a parameter called max allowed packet. This is the maximum size of a packet that you can send over the network in MySQL. In Wix, we limited to 512 megabytes, but we're not going to use JSON document inside MySQL in this size. We're keeping it at the size of 1K, 2K, maybe 4K, but I'm not recommending to use 1 gigabyte of document, JSON document inside the table inside MySQL. It's not very good practice to do that. MySQL is not a storage, it's not a storage engine. If you want to keep large JSON, you can use external storage in Mongo, or you can use S3 or other object store. We're not using that to keep large objects, only very, very small JSON objects. So not like a blob, JSON need to have character set. So you cannot keep every character set. You have to use UTF-8. And if you have some strange data inside the JSON, you cannot use JSON data type. You have to use UTF-8. Also, JSON column cannot have a non-null default value. In MySQL 8, they fixed that, and now in MySQL 8, you can have a non-null value. But if you want to use a default like empty JSON, you cannot use empty JSON as a default value. You have to use a null as an empty value, as a default value. In 8, you can use a function-based default, and you can use empty JSON instead of a null. Okay, a little bit about more limitation. Okay, so why we're still using, why we like to use, we're not moving to MySQL instead of Mongo. We're still keeping our Mongo databases. We're still using Mongo databases. And why we're not just move everything to MySQL? Just take all the JSON we have and just move to MySQL. So we found many limitations in MySQL about using JSON and document as a document store. So until now, MySQL doesn't have any sharding solution, not in place, not inside the software. No online DDL. So we still have issues with online DDL. Also in 8, you cannot. We have lots of issues with online DDL. Most of the DDLs, most of the alter table need to have a lock on the table, and this is a big issue for us. We cannot just lock tables. We have to be online all the time. Less efficient compression. We found that the compression is still not efficient enough. So for big JSONs, it's not efficient enough. BSON is better until now, and BSON or compression like a glib or something like that, or zlib, it's faster and more compressed than MySQL, but it's good enough for small JSON. no full support for availability for Xdev API. I will not going to talk about Xdev API, but if you want to know, Xdev API is a connector for a CRUD interface to MySQL. And we wanted to use CRUD interface with MySQL, but for now, it's not mature enough. The Xdev API is not mature enough, and we cannot use CRUD interface inside MySQL. So we're still keeping the Mongo for CRUD interface and also for big JSONs and complex JSON, complex documents, and no advanced indexes. In MySQL 8, we have more complex indexes in over JSON. We can use function-based indexes over JSON, so it's more complex than in 5.7, but still we don't have, for example, TTL indexes, and we're heavily using TTL indexes in Mongo, and we still doesn't have it in MySQL. We can create software solution for TTL indexes, but still we don't have this solution yet. So this is why we're still keeping the Mongos and all other document databases. Also, okay, so how we can combine document store with relational model? So we have lots of JSON. MySQL comes with a lot of JSON functions. We have lots of JSON functions like JSON object, JSON array, JSON extract. Here I give you a link to all the functions, and all the functions are working also on text. So if you don't want to convert to JSON data type, you can still use all the function over text data type, and you just can see how it works before you convert to a JSON data type. You have to take into account that it's work 10. The JSON will work 10 times worse the text from JSON, because it's not JSON, it's not real JSON. The MySQL have to convert it to JSON in the memory and then run the function. But you can still use all the functions with text without converting, just to see if it's working, if you want to convert everything. And use JSON path syntax. I will show an example. And the best feature of all, you can use JSON. And also I will show an example for that also. So let's see let's see a little bit about the JSON function. I will show a very small example. We have lots of JSON functions. I will show only a small example of that. Okay, so you can do a select on you can create a JSON object. So you just do a select, first name Robert, email, and the output will be a valid JSON object. This is how we can create a valid JSON object from other types, or from other strings, or from other rows that you want to convert to JSON. Also, we can create JSON arrays the same way. You just put the variables, the variables inside the function, and we get a valid JSON array. Also, we can use JSON extract. JSON extract can run as a function with the column name and type. I will show an example. And also, we can use JSON extract as a JSON path, as a jQuery. We can use jQuery inside MySQL, inside queries, inside SQL. It's very helpful because it's very fast to use and very helpful to use, and you can just copy paste from JavaScript or to whatever JSON path you're using, JSON query you're using, and a jQuery interface you're using, and just run it inside MySQL. So it's very helpful and very quick and very, very nice. So this is example for JSON extract. You can select JSON extract. So here we're adjusting the first name. You can see we're selecting the attribute with the first name. You can go whatever level you want. You can run like 2 levels and 4 levels inside the JSON. You can run how many levels you want inside the JSON and extract the attribute. And you can extract multiple attributes also. So here I am extracting only the first name. So you see I'm extracting from the JSON the first name. Here is the JSON path. So we can use the JSON path inside the select or in the where path. So Here we can use the select. Inside the select, so I'm selecting the nickname and the email, and I'm getting the nickname and email. And you can see here we are using emojis. This is a real copy paste from the database. So you can use emojis. This was a big win for us to use emojis inside JSONs. So here we can use the JSON path. As you can see here, it's JSON path inside the select, and the workloads is regular workloads. This is a regular attribute, email. And you can use also inside the workloads. You can use the workloads as a JSON, as a jQuery. So we can use jQuery inside inside the workloads. So here we can use email like true. If the email is verified, we can get a count where the email is verified. Okay. Now we can use JSON contains. JSON contains is we can select if there is a tree inside the JSON array. So do we contain tree inside the JSON array? And also JSON keys, we can return keys inside the arrays. If the keys, we can get the keys from the JSON object. So I want the key for B. So it's C. I want the keys inside the B array. Sorry, the B object. So the C is the key in the B object. Okay, and here we have if it's contained inside the array. Okay, so we can use JSON path. JSON path is partial update of and replacing existing value inside a JSON. So we can set whatever we like. So here we're doing we change the gender for Jean. So we change gender to from male. We set from female to male. You see, gender is this is the original JSON, and the gender is female. And we change the gender to male, and this will set the attributes. So in MySQL 8, you will do only a partial update of the JSON. This will replace only this attribute inside the JSON. In 5.7, 19, and forward, it will replace all the JSON. This is one of the limitations of partial update. To replace all the JSON and also replace this attribute. In 8, you will replace only this attribute inside the JSON, inside the storage. And we can do JSON insert, so we're insert value and new value without replacing existing values. So just appending new values. Here also we're replacing only existing values. So if the value is not exist inside the JSON, we'll get an error. Okay, so here we're replacing only part of the values. We don't have the C. Okay, so it will not replace the C. We don't have any C value. Okay, so this is the functions that we can use inside JSON, inside the JSON data type with the JSON data type. And in 5.19, we get also a new feature called generated columns. This is very helpful. This is a very helpful feature. The feature means that we can create a column we can create a virtual column. We can create a column by a function. So we have two types of generated columns. I will show an example, but we have two types of generated columns. We have the virtual column. So the virtual column is created on the fly. The data will not stored in the data file. It's just going to generated through the query. Before the query will run, it will generate the result. The MySQL will generate the result. And the stored will keep the value. I will show example what I mean, but when you create generated column with stored value, so the generated column will keep the value that we generated inside the data file. So it can work faster, and you can create primary keys on top of the generated column. So what is the difference between store and virtual? So store, you can use primary and secondary keys. We can use B-tree, full text, and GIS indexes. It requires table rebuild. If you want to add another column with the stored attribute, you have to recreate the table, and it's not online. If you want to use a virtual generated column, you can use it as a secondary key only. You cannot use primary key on top of it. It's only B-tree index, but you can use it mixed with other fields. You don't need to table rebuild. You can create whatever you want without downtime. You don't need to rebuild the table, and you can insert whatever you like. You can you have an instant alter and faster insert, because when you insert a data, it will not kept inside the JSON. I can see that we have Q&As. I will answer all the questions later in the end of the presentation. Okay. Okay. So bottom line, unless you need primary key or full text on some strange index, you can use virtual columns. We already tested virtual columns, and it's faster as storage. You don't need to worry about data generated from the query. It's very fast. We don't see any difference when you run queries between virtual and stored. And they also the indexes are very, very fast. Okay, so how we can create generated columns? We can create table T1, and the first row is integer, and the second one is generated. The C2 is generated from C1 plus 1, and it's virtual. So the default will be virtual. So if I'm going to select it, I'm going to see everything like C1, C is going to be 1, and C2 is going to be 2, and 3 is going to be 4, and this is how it's going to generate it. So, but if we want to convert it to store, we have to drop first the virtual column. This is also a rebuild table, and also we need to create a generated with the store key, and then after the alter, it will store this value. The C2 value will be stored inside the table space. So this is the difference between store and virtual. So how we can create a virtual column? How we can use virtual columns, generated columns? Sorry, how can we use generated columns to our benefit with JSON? So just an example, we can create a container like in Mongo. This is an example of a Mongo container. We're going to create item tables, and we can use a doc as a JSON. JSON. Inside the JSON, we have attributes called _ID. And the _ID, we can create it outside the JSON with generated column. And we create it like, we use the function JSON unquote just to remove the quotes. And JSON extract from the docs, we convert it to UTF-4. We don't have to do that, but if you like, you can convert it to UTF-4, UTF-MB4, and the ID. And stored, not null, and it's stored. And now we can create primary key, because it's stored, we can create primary key on top of the ID. So now the primary key is coming from the JSON document. So the only thing I need to do is just insert a JSON document inside this table, and automatically we'll get a primary key from the JSON. So the developer only need to know the JSON, the doc, only need to know the JSON document. You can change the JSON document, we can use the JSON document, but it doesn't need to know about every other rows. I can create another rows in the tables, and it be transparent to the developer, because the primary key is coming from inside the JSON, and I can extract other columns from inside the JSON. The developer doesn't need to change anything from his point of view, and the DBA doesn't need to change anything from his point of view. So we're creating like a document store from a MySQL table. Okay, so what we are doing at Wix and why we're using, why we try to use JSON data type. So why JSON data type? Okay, so we have two major issues in MySQL at Wix. DDL on the large tables. We have very large tables in Wix. Lots of terabytes of size, like 10, 15 terabytes. And the big issue is DDL time. So adding a new column to a table is it's a rebuild table. It's taking a long time. Adding new attributes to a JSON, we don't need to do anything. And also adding a new generated column, as long as it's virtual, we don't need to do anything also. It's seamless. It's not rebuild. It's just alter table, add virtual column, and that's it. It's not downtime. You don't lock the table. It's very easy to do. In Wix, we're using lots of blobs. All the blobs are JSON-like. Most of the data inside the blobs look like JSON. Most of them is a real JSON. It's not even look like. It's a real JSON data. We have large tables and become quite IO consuming to update all the JSON, all the blobs. If you want to extract data from the blob, you need to take all the blob outside. You need to work on it with some Java code or whatever code you like, and you need to extract the attributes outside of the blob. You need to extract the compression. You need to read all the attributes. You need to extract whatever attributes you need. It's very IO consuming, very CPU consuming. You need more servers to do the MySQL job. Only the job of the MySQL. So what we're doing, we started to migrate lots of blobs to JSON. We're not going to migrate all the blobs. Why? Because JSON columns have larger disk footprint for blobs. So if we have large blobs, we prefer to use the compression of the blob, and the compression is better. We can use better compression with the blob, and if it's a large blob, we prefer not to open it and put it as a JSON. Also, if you're using encryption, we cannot encrypt with the community edition. We cannot encrypt the JSON inside the MySQL. If we want to use indexes and we want to use queries, we cannot encrypt the JSONs. So if we want to encrypt the data, we cannot use JSON. And also, if the data inside the blob is not a real JSON, we cannot convert it to a real JSON. We're going to keep it inside the blob. So you have to notice that if you want to move data inside the JSON data type, it has to be JSON. It has to be validated as a JSON, because you cannot just put a string inside the data type. It will fail. Every insert, it will validate the JSON. Okay, it will validate the insert. So I'm going to show you an example of how we are using this method. Okay, so we have this almost real example. This is an almost real table inside Wix. So we have create table, appointments, and we have appointments table. And inside the table, we have lots of appointments. And one of the rows of the table appointments is ink data. It's not encrypted. It's just ink data. I don't know why they call it ink, but it's ink data. It's medium blob. And the medium blob contains this JSON. And we wanted to get out the payment type. We noticed that you are using payment type a lot, and we query payment type a lot, and we need to query a lot of the payment type, and the payment type is inside the blob. As you can see here, the payment type is inside the blob. So if you want to know what is the payment type, you have to extract the blob, you have to open it, and you have to look for the attribute inside the blob, and you have to extract it. You cannot query the payment type. If you want to query the payment type, you have to extract it. You have to create a row, a new row inside the table, you have to create a migration to extract the data from all the blobs and put it to insert it in the database. So we didn't want to do that. We need to find another way to do that. And we found this way. We just alter table and we created a JSON column. This will be, this is not this is the first not online. You have to do a rebuild, table rebuild. But still, it's only one table rebuild, and we added a JSON column with in place algorithm. And with block none, we are using lots of tools to create an online alter, so it's not really downtime, but it's not a nice procedure. It's not very fast and seamless procedure. And now, after we use sorry. So with in version 8, it's going to be an online procedure. You have the algorithm in place, and it's going to be online. So from version 8, you can use JSON data type as an online alter, online DDL, and you have the ability to use non-value default, null default value. Sorry. Okay, so in version 8 that we still don't use, you can do it online. Okay, so next phase is data migration. After we created the JSON column, now we can convert, we can move the data. Sorry, I will show you this slide and then we can go back to the other slide. We can convert the data. We didn't do it like this, we did it with a code, but this is an example of what we did. We can convert the data to a JSON from the ink data. We just convert from the blob to a JSON. We just update the appointment set ink data date JSON, and we convert from the ink data using UTF-MD4. And you also can convert, if you don't like to use JSON data type, you can do whatever you like. You can use text data type. It will work less efficient, but you can do that. If you afraid to JSON, don't like to use JSON data type, you can still use text data type. And this is what was the migration, all the landmines and the issues of migration. So we need to migrate all the data from blob to JSON columns. So the JSON data type validate JSON on insert. So you don't need to validate. You have to validate before all the JSON data. If you don't want to get exception every time you get a invalid JSON, you have to validate before. Data you have to store. The data have to be stored in UTF-MD4. So if you have like a strange characters inside the blob, you have to keep notice, and you have to convert it before. You will get an exception. Also, mismatch sizes. If you have part of the same document, you have, for example, integer, like a name. You have most of the document, you have like price, and you have attribute with the name price, and most of the documents have price, have a real price, have like 5, 10, 11 integer. And one of the documents have like, I don't know, name, $10 with the description, with string, $10. So it will not work. Sorry for 1 second, I need to let out the cat. Sorry, just a second. I'm very sorry. The cat is interfering with the presentation. Okay, so let's get back to it. Okay, so if different value, it can give you, if you create an index, for example, on top of the attribute, you will get a mismatch value and you get an error. You cannot index, in MySQL, you cannot create index on integer and also on string. So you need to check the data before you do the migration. Or during the migration, you have to check the data, because JSON will never enforce types. So we can create different JSONs with different types with the same name. So you have to enforce it. You have to enforce before the data types. You need to take this as an account. Okay, so you have to validate the data before. You have a function validate JSON. If you want to use the MySQL, you can use. There's lots of code, Go libraries, Golang libraries that you can validate JSON. You can do it whatever method you like. You can use Java. You can use Golang. You need to validate the data before. Fix invalid rows. Because blob can contain multiple character sets, you need to convert everything to UTF-8 or at least to ASCII or UTF-8. You can run the migrate and then drop the blob column. And then you can create generated columns and indexes. So we talk about the conversion. So you can use MySQL to convert. If it's a very small set, you can use this update to convert the small set. And after we converted, so I can show the explain, we can just run whatever you like with the query. So now we can just run query with JSON and see what the payment type is. So we run the query, select count from where ain't data JSON is, and the payment type is offline. And we got how many payment type you get that are offline. But still, we have a very good performance, and we can query the JSON. It's not blob anymore. We don't need to use external application to read it, but the performance is not very good. As you can see, the query cost is very high, and the access type is all. So it's full table scan. It's running full table scan on the table. So it's not a very good solution because although we're running a query on top of the JSON, it's not very fast, and it's going to do lots of full table scan, and it's going to use lots of I/O for that. So what is the solution? How we can improve the performance? We can improve JSON queries. We can improve JSON queries by creating an index on the relevant attributes. We can create generated columns on the JSON attributes and optimize the index to use the columns. So this is the example. I wanted to create an index on top of the appointments. So I created the generated column on appointments. So I created alter table appointments, add column payment types. Okay. So I'm extracting the payment types outside with a virtual column. I don't need to do anything, just create the virtual column. And JSON extract is the function that I used for the workload. So I'm converting to MB4 and getting the payment types outside to the table. And then I will create index on top of this row. So I'm creating a row, I'm creating a column, and also I'm creating an index on top of this column. This is all I did. And all of this is an online DDL. And it's very important to know that in MySQL 8.0, I think 90, I don't remember, 8.9, I think. I don't remember the exact version, but from 8, you don't need to do the first step. You just can create alter table, add index, and the MySQL will automatically create the virtual column, and you will not see the virtual column. It will be hidden. So you can just create the index, and that's it. You don't need to create the virtual column. And in MySQL 5.7, you have to create a virtual column, but it's very fast and not very complex procedure. And now, if we're running the query, we don't need to use the column. As you can see, I'm still using the jQuery, sorry. So we're still using the query, and I'm not using the virtual column. I'm just using the same query. The MySQL will know I have a virtual column, and will know that I have an index on top of this attribute, and will automatically use this key. You don't need to use the column. You can still keep the old query. So the query cost is much less and is very fast, and you're using the index. everything is look very cool. So what we did, from no ability to query blob, now we can online no rebuild table schema change. Now we can add virtual columns, whatever we like. We can add indexes, whatever we like. We cannot drop what we can add. Drop is still offline. We cannot drop. We can support UTF-MD4. We have partial updates in MySQL 8. And also we have partial updates on JSON, but it's not partial updates on top of the data file, but it's still, you can partial update the JSON. We have JSON query capabilities, and we have index on top of the JSON attributes to improve I/O and size of the disks. We lost the first-time migration. We need to run very long migration and very hard migration and very painful migration. The migration is very hard to do, but it's only one. Easy to save binary data with no character set. So now we are keeping the character set as UTF-MD4. So we are losing the binary way to save data. So we have to use character set. We cannot just drop whatever character set we like inside the blob. We lost the compression, and also we lost the encryption. We have to handle the compression and the encryption ourselves. We didn't figure it out yet. And also, I like to share with you a small, it's not small, but it's a small result of a benchmark we did. We did a very large benchmark between blobs and JSON. The end result, we found out that the blob will work faster, but I think the benefits of the JSON is much, much greater than the little bit, the 5 to 10% win of the blob. Because of the blob and the compression, the blob is a little bit faster than, a little bit smaller in the table, and a little bit faster than the JSON. But we found out that running on primary key is the same, less and more the same. The blob is a little bit faster because it's smaller. The blob itself is smaller. But if we're running complex queries and we're taking into account all the alter tables we need to do and all the extra servers we need to extract data from the blobs, it's much, much faster and much, much cheaper to use JSON. We found that we're using JSON more than blobs.